So a little bonus stuff for us from section 8.8. It's going to start out with this little reminder here. If you have A minus B over B minus A, basically the same terms, both being subtracted, just a different order. That simplifies to -1. That's a good thing to know and to keep track of. Now, let's turn our attention to this first example. I like this because it gives you a variety of factorizations to deal with. Now, you may find it helpful to think of this as being over 1. That might be helpful. Now, I said it gives you a good variety of things to factor, and let's start with this one down here in the denominator. That one's the difference of squares, right? So hopefully you can help me factor that one. What do I square to get the first term?
Is it 9?
9, and then C minus what? What do I square to get that term?
X.
Good. 9C minus X, and then 9C plus X. Cool. Now this one up here, that's got 3 terms. Now if you're thinking about factorization strategy, we've got 3 terms. It has leading coefficient of 1, so that's the easy case. You're looking for 2 numbers that multiply to 7 and add to 8.
7 and 1.
Good. 7 and 1. Now over here, that's got 4 terms. So that's yet a different factorization once again. When you have 4 terms, the idea is to factor by grouping, right? So let's see if we can't do that. Maybe squeeze it in up there. Let's see. So from those first 2 terms, I can factor out an X, which leaves behind X plus 1. From these second 2 terms, I can factor out a 9C. In fact, a -9C, which also leaves behind X plus 1. Are we comfortable with that? I just factored the first 2 terms here, and then the next 2 terms here. Notice I factored out the -9, and in doing that, it changes the sign on both of those terms so that these binomials match. And that's a good thing. Let's finish this off. I can take out an X plus 1 from both of those terms. What gets left behind if I factor out the X plus 1?
X minus 9.
X minus
9C.
9C. Nice. Nice. I think that's it. It's as far as we can go. Now, do I get any cancellation?
Can't you multiply a -1 to the X minus 9C and then cancel that with the 9C minus X?
So there's 2 different ways you can handle this. You could factor out a -1 if you wanted, similar to what you just said. Or you could use my little reminder that I started out things with. Because these are opposite, I mean, it's just the same terms, but opposite directions, X minus 9C, 9C minus X, I can cancel it and just write a -1. That's probably the easiest way to handle it. If you're not comfortable with that, there's other things you can do, like you suggested. You could factor out a -1. That would turn this into 9C minus X, and then you could just cancel it right away.
So when you do that, where does the -1 go? Like, does
I
it just
put it in the numerator, but you only put one -1. You don't put it in the numerator and denominator. You put it in the numerator.
So then right now the numerator would be X plus 1 and then -1, right?
So really this is multiplying everything.
Okay.
In fact, that's the only thing that canceled was that term. So I've got a negative, which I'll write in front. And then I got X plus 1 times X plus 1. So I'll write that as X plus 1 squared, and then X plus 7 all over 9c plus x. So that's the way I would finish writing it. But I would just leave the negative out there. Now, the negative does cause some issues for people. So let me show you a different way to handle that negative if you're not comfortable with that kind of cancellation. So kind of sticking with the same problem here. If I had x plus 1 times x minus 9c over 1. So this is all the same. I'm just going to do it different this time. Let's see, 9c minus x and 9c plus x. So let's say that I was looking at these and I noticed, you know what, these are kind of the same. If I wanted to do a direct cancellation, that's more in my comfort zone. What I could do is I could factor out a -1 from that numerator term. So it would look like this: x plus 1 times -1. Now, when you factor out a negative, it's going to change the sign on the terms inside here. So that will give me a 9c minus x. And the rest of this is going to stay the same. But if you check it, -1 times 9c gives me -9c. -1 times -x gives me +x. So now I can do my cancellation like I did before. Those two terms disappear. And like before, I've got an x plus 1 and x plus 1. That gives me my x plus 1 squared. I've got this term still, but I've got my negative out in front. So it depends on what's in your comfort zone as to what you're going to do in terms of taking care of that factor of -1. But one way or another, do look for that. Okay, so any comments or thoughts on this one? Anything more you'd like me to say here? Let's keep going. We've got a number of examples here. So we'll call this one example B. And it's 9x plus 8 over 5x plus 15 minus 5x minus 4 over 5x plus 15. Well, there's good news in this one. Does anyone know what the good news is? You've got common denominators. Yeah, the denominators are the same already. Thanks, Samantha. So if the denominators are the same, then you can subtract the numerators. So let me just write 5x plus 15 here, and then 9x plus 8 minus 5x minus 4. Except I've made a mistake. And it's hard to see. Go ahead. What's the mistake?
You have to distribute the negative to the 5x minus 4. So it'd be -5x plus 4.
Perfect. Let me do it this way. Let's put parentheses around that. And here it makes it a little bit more clear what you were just saying. That is, I've got to distribute that negative. To get rid of the parentheses, I got to distribute that -1 here. So that gives me 9x plus 8 minus 5x plus 4. So you got to be careful with that, because if you had a -4, then I'd end up with 8 minus 4 would be 4. Whereas here I end up with a 12. In fact, I end up with 9x minus 5x is 4x plus 12 over 5x plus 15. I'd be happy to tell you we're done, but we're not. We got to look for some more simplification. You can't cancel the 3's here. You can't cancel the x's here. But what you can do is you can factor this. The first thing you always look for in factorization is a GCF. If I factor out the GCF, I'm left with this. Am I done now?
No.
No. Here you cancel out the x plus 3 over x plus 3 and end up with 4/5 for an answer. Yay. That's done. So we are done here. So you just got to be a little bit careful when you're subtracting to subtract. Maybe put parentheses around this like I did so that you distribute that negative to both terms. Now, we were lucky in this one because we started out with a GCF. We're not always going to be quite so lucky. So let's take a look at this example. 6 over x squared minus 2x minus 3 minus x over 5x squared minus 13x minus 6. Do we have common denominators here? No, not even close. So what you're going to need to do first is figure out what the common denominator is. And that's going to mean factoring. Now, I will tell you that these things are always going to factor. Always. Now, this one's going to be a pain. I might just help you out in the interest of time with that factorization. Maybe we'll go back and figure it out in a minute. But let's start with the easy one. I know I have to have an x and an x. Because this is negative, one of these has to be positive, one of them has to be negative because they have to multiply to a negative number. So they can't both be the same. Not too many numbers multiply to 3. It's just 1 and 3. But which one of them is positive, the 1 or the 3?
The 3, right?
The one.
The 1.
The larger one is going to have this sign. So the larger one has to have the negative sign. The smaller one's going to have that one. Now, I'm just going to help you out with this factorization in the interest of time. 5x plus 2
Square.
over x minus 3. And now we're going to need to figure out, well, what's the LCD here? What's the lowest common denominator? Well, I know I need an x plus 1, an x minus 3, and what else? I've already got the x minus 3. 5x plus 2. That's my lowest common denominator. In looking at what I've got, I realize I don't quite have the LCD there. So
the LCD is all of that?
all of that.
Okay.
So let's look at this. What am I missing here that's part of my LCD?
You have to square x minus 3.
No, I've got an x minus 3.
You're missing 5x plus 2.
I'm missing the 5x plus 2 term. So I'll multiply by 1. Multiplying by 1 doesn't change the value of my expression, but it will give me an equivalent denominator to my LCD. So that's what I want. What am I missing here?
X plus 1.
X plus 1. And I'll multiply by that in the numerator and denominator. Okay. let's clean this up a little bit. That's going to be 6 times 5x is 30x plus 12. And here I'm going to get a little bit lazy for a minute. This is my LCD. Over here, somebody distribute that for me, please.
Would it be negative x squared minus x?
Yeah, you could distribute the negative if you wanted. I'd have to change this sign here.
Sorry.
No, it's okay. No, that's great. You know, I like that you did that. I'm not sure most people will or not, so I'm gonna assume they won't. But here again, you're subtracting. So let's put that parenthesis there. Let me pause. Make sure you're still with me. We first figured out what the LCD was. That was this term. Then we said, all right, I need each of these to have the LCD. I multiplied by the missing term here, and I multiplied by the missing term here. Notice that when I multiply, I'm multiplying by that over itself. You have to, because equivalently, this expression is equal to 1. And when you multiply by 1, you're not going to change anything. Now, this form of 1 will make it look different, but that's okay. It still has the same value. If your boss offered to multiply your paycheck by 1, you're not suddenly going to put them on your Christmas card list. All right? It's still going to be the same. Now, let's finish this up. We got a little bit more to do. That negative has to distribute itself. This is going to be 30x plus 12 minus x squared minus x over the LCD. Are there any like terms I can combine? Yeah, the 30x and the minus x. Good. So I'll write this in order, decreasing powers of x. So there'll be a negative x squared plus 29x plus 12 over the LCD. Now, I don't think that WebAssign is going to accept LCD. It's okay in your writing, but when you're all done, you're going to have to write x plus 1 times x minus 3 times 5x plus 2, which is that last term that is hardly legible. Okay, not bad. That's it. In some of these problems, you got to look and see if this is going to factor any further and get some cancellation like we did with example B. But I'll just tell you ahead of time, there's no more cancellation there. Just not.
For the lowest common denominator, there's no order. There's no like particular order for it. I could put it in any.
Yeah, you
way.
could write it in any of, actually there's 6 different orders there for that. It's a number that maybe I'll explain sometimes called 3 factorial is 6.
Okay.
Wait, can you go over that numerator again and the answer?
Got it. Okay, now I get it.
Sure. Are you okay up to here?
Yeah, I will be.
Yeah. Well, let's back up then. So we needed to introduce these terms, this one and this one, or this one here, to have my lowest common denominator. When you do that, you have to multiply by something over itself. So that was the x plus 1 over x plus 1. This is my lowest common denominator. So I saved myself some writing by just putting LCD instead of writing that all out. Not a big deal, but in the numerator, I distributed the x squared plus x. Here I distributed the 6. So I got both of those terms. Then I said, you know what? Let me put a parenthesis here to remind myself that as I subtract these, when I bring these together, I've got to distribute that net to both of these terms. The 30x plus 12 stayed the same, but both of these terms changed in sign. It gave me a negative x squared minus x. Good
Got
here.
it.
Okay, thank you. And then finally, we combine like terms. There wasn't much in the way of like terms, but here I had a 30x, and here I have a minus x. So 30 minus 1 is 29. So that's where the 29 came from. I put the 12 at the end, and the minus x squared I put out front.
Mr. Parent, I have a quick question.
Thank you.
Good, Bailey?
What?
Oh, I just said thank you.
Yeah, okay. Lourdes?
So this was like the two fractions being subtracted, so which is why you found the least common denominator. But if it comes to it, like if it's like a fraction times a fraction, like when do you have to use the least common denominator and make sure they're both the same? Is it any time you're multiplying, adding, or subtracting fractions?
It's a great question. It's when you're adding or subtracting fractions.
Okay, so when you're
multiplying or dividing, you don't need a common denominator.
Okay.
But when you're adding or subtracting, you do need a common denominator.
Okay, thank you.
Perfect, thank you. Okay, so let's do another one. Example D. Example D is going to be a little bit more friendly. And it kind of goes to your question, Lourdes, just a minute ago, where you need a common denominator. And you need a common denominator when you're adding or subtracting fractions. But guess what? I'm dividing fractions. I'm going to regard that as one fraction and this as another fraction. So I'm dividing this by this. Now, if you wanted to, you could write that as 12x divided by y divided by 15xz divided by y squared. But do you remember what happens when you divide by a fraction? What's our rule?
We flip.
Good, you gotta invert and multiply. So this is gonna be times, and maybe I shouldn't use a little times there. I should use a dot. There, never happened. Times the reciprocal of that second term. So y squared over 15xz. Now I can simplify things. I don't need a common denominator to divide or multiply. So I'm just going to copy the problem over here and then do my simplification / cancellation. Let's see what can go. Well, I can get rid of one of the y's. Can anything else disappear? Or am I done?
You can divide by 3.
Well,
All right. 3 goes into 12 4 times and into 15 5 times. Nice. Anything else?
The x?
Yeah, the x disappears. Let's take stock of what we have left. So we've got a 4, the x is gone, and one of the y's is still here. So 4y over 5z. And that's it. There's your answer. One last one. So example E. I'm going to milk this one for all it's worth. So you might see an expression of f of x equals 3x squared plus 45x over, say, x to the 4th plus 15x cubed. And it's going to ask you to do two things. First, it's going to ask you what's the domain, and second, it's going to ask you to simplify this. So let's work with the simplification first. So to simplify a function like this, you're going to factor it. So let's take a look at the numerator. This is not the sum of squares or the sum of cubes. In fact, what is it? What can I do here? How can I factor this one?
You find the GCF.
Perfect. The very, very first thing you always do when factoring is look for the GCF. So I'm not sure why this is not letting me scroll up, but you're going to look for the GCF. And all right, I'm kind of losing the momentum here. Yeah, but factor out the GCF is if there is one. Perfect. So there is a GCF in the numerator. It's 3x, which leaves behind x plus 15. In the denominator, there's also a GCF. What is that GCF?
Would it be x squared?
X squared is a common factor, but you can actually take one more out. X cubed. Yeah. So x squared is not wrong, but if you want to take out the greatest common factor, it'd be x cubed. Now, these do cancel. I do get some cancellation. In fact, I'll do that. I'll leave some space here to take care of that in a minute. But remember, you're going to be asked for two things. One is to simplify, and the second is the domain. So B is the domain.
So we take away the x plus 15. We cancel those out?
Eventually. Eventually. So for the domain, you remember domain is associated with which coordinate? Is it your x coordinate or your y coordinate?
X.
X.
It's the x coordinate. So the domain of this is what I can put into this function and have it work. Now, there's really only a couple places where something might not work. One of them is if you have the square root of a negative number. All right. Negative number. That's a problem. But the other problem is dividing by 0. You can't divide by 0, but that could happen here. In fact, let's think of this little part right here. Is there a value of x that would make this expression 0, that x plus 15? Is there a value I could put into x that makes that part equal to 0?
Negative 15.
Negative 15. So your domain can't include that. So your domain is going to be x not equal to negative 15. You can't put in a negative 15 here and have things work. Is there another value that would give me a 0 in this denominator? Another value for x?
Negative x?
But that's not a number.
Would it be 0?
0. So x can't be negative 15 and x can't be 0. So those are the values that you would have to avoid. If you were to put that on a number line, it'd look like this. Everything here and everything here. You're just avoiding those two numbers. If you had to write it in interval notation, it would look like this.
Union.
I'm not sure how they're going to want you to input it, but there's 3 different ways that you could list it. It might just ask you for the values of x that you can't put in. All right. Okay. Let me get you to do your groups so you can keep working on this. And if you have some questions, please reach out.
Can you check in on us?
Wait,
Checking on you in what sense?
Like, just say, hey, how we doing? When you pop in, just
I will buzz in. I got called into a couple groups in the last session, and if you have a question, please raise your hand.
did we
Okay.
simplify for example E? I
Oh.
thought we only figured the
Oh,
domain.
you're right.
Yeah.
Thank you. We didn't.
I was thinking
finish
about
simplifying.
that.
So to finish simplifying, and I really appreciate it. Boy, I'm glad I didn't stop the recording. That's going to cancel, right? And it leaves me with 3x over x cubed. But even that's not simplified enough,
because
right?
you can take that x away from that one, so it'd be x squared, right? At the denominator. So 3 over x squared.
Perfect. Thank you, Tabitha.
Yeah.
Yeah, 3 over x squared. Well done. Well done. So there's your part A. Here's your part B.
Wait, how'd you get the x squared?
You
You
subtracted
cancel
the
out
x.
the
and-
x.
Subtract.
Yeah,
Cancel out
subtract the
the
x
x.
from the top.
So like 1 minus 3?
Yeah, that's literally what's going on. You're subtracting out that x. All right, well done.